So again, my name is Xander Evans. I'm the research director here at the Forest Guild, and I'm also a board member on the Southwest Fire Science Consortium. So in my consortium role, I recently worked on an overview of the 2013 fire season in the Southwest. And so many of you may have seen the publication that came out, I guess, looking at the title here, in February. But it was an attempt to try to provide some quick overview of the last fire season, so that as we get into the 2014 season and onwards, we have some way of referring back and a quick reference for what happened in the 2013 fire season. I think all too often the public and even those of us in the fire community hear about individual fires and, well, they're burning, and maybe some of the response, some of the suppression response, but don't necessarily hear later about what the fire effects were or some of the other after assessments. So that's what this report attempts to do, and it can be downloaded from the Southwest Fire Science Consortium website, and later I'll put that link in the chat box. So in this report, we covered the 8 largest fires in the Southwest. So that's Arizona, New Mexico, and apologies to Texas. We didn't include fires in Texas because most of the consortium is focused on Arizona and New Mexico. And these fires, there were a lot more fires in the Southwest, but these fires accounted for about 70% of the acres burned. So by honing in on these 8 largest, we covered the majority of the acres burned. 2013 was actually a relatively light year in terms of wildfires burned. You can see that 2011 was a big year in the Southwest, and of course this amount of acreage burned, it was dwarfed by pre-settlement times, the number of acres that would burn every summer. But in modern times, 2011 was a big fire year, and 2013 was relatively small. So in the second half of today's webinar, we'll hear a little bit about what we might expect for 2014, but this gives us some way of putting that in context. So one of the questions about this report is how to get the data, and there are a lot of different sources, a lot of different options for collecting data on fires. And so we chose in this report to focus on publicly available data so that other people could replicate our results or extend them and look into other variables that he or she is interested in, or combine them with other areas. So one of the key data sets we used was Landfire. That's a seamless wall-to-wall coverage of the entire U.S., and it has a number of different elements. You can sort of see some of them, things like disturbance, vegetation, fuel, the fire regime, topography, and so all these elements can be freely downloaded from the Landfire website, and these formed this was the backbone of much of the analysis for this overview, including things like vegetation type. We also used maps of the wildland-urban interface. So as many of you know, the WUI, as it's referred to, is a pretty big issue in how we deal with fires, how we suppress fires, how we approach fires. And so we wanted to include some metric about the WUI, about population, and rather than, there's a lot of arguments about how this should be done, and rather than wade into the methodological debates about how to measure WUI or map WUI, we used an existing map that covers the whole country. One of the reasons we focused on these national level maps or GIS data sets is that we didn't want data that ended at a particular boundary. So we didn't want data that ended on Forest Service boundaries or private land boundaries or something like that. We wanted something that we could do across all those different ownership types. And that's one of the reasons we chose this WUI map. that's actually produced by, I believe it's the University of Wisconsin, if I'm not mistaken. We did rely on a number of Forest Service data sets. The U.S. Forest Service Remote Sensing Applications Center does creates maps for burned area emergency response. And it's interesting, they're on their website they're labeled BARC maps, but I was told that's not a term they like to use anymore. So I think that will be changing. And really, these maps are soil maps. They're maps of the burn severity from a soil's perspective. So they're soil burn severity maps. But they've been in use for a number of years and form a good way to assess how hot and how severe fires were. Newer maps, also from the U.S. Forest Service, are the Rapid Assessment of Vegetation Condition After Wildfire, or RAVAGE. And these maps use a somewhat similar remote sensing methodology, but their goal is to capture a different attribute, and that is the mortality of the vegetation, the canopy. And so as we go through some of these maps from the 2013 season, I think you'll see that there's some crucial differences between these two kinds of maps, one measuring soil burn severity and one measuring canopy burn severity. For the actual fire boundaries, these can change a lot, and they're around the edges. I think there could be some debate about their accuracy. So we went with the most official source we could, which was this repository of fire data managed by the U.S. Geological Survey. Again, publicly accessible, and so you can go on there and download last year's fire data, or as the 2014 year starts up, this year's fire data. We also used INCIWeb. Probably many of you use this site for fire information as it's happening. INCIWeb is not an archive, so eventually the information that we accessed on INCIWeb will disappear. But for the time being, you can still go on and see, say, 2013 fires and get some of the key information, like when it started, how many acres it burned, and that sort of thing. Acres burned is another example where you'll see a lot of different numbers, and so we decided that INCIWeb was probably the most authoritative public source. So with that, I'll dive into the analysis of the fires themselves. The first one is the Silver Fire. This is the largest fire in the Southwest. It covered a total of 138,000 acres, and it mainly burned in mixed conifer. So right here we're looking at the soil burn severity map, and you'll notice large patches of high severity effects for soil. And you'll also, another key element that I thought was interesting was that there are a number of fires like the Granite Fire from 2003, the Granite Fire from 2007, the Saco Fire, Morgan Fire. A number of fires burned on the edges of, or I should say that the Silver Fire burned on the edges of previous fires. So one of the things that we're seeing in the Southwest now is more and more of this fire scar overlap. But you'll notice in, say, the Granite Fire burn scar, most of the soil effects were pretty minimal. And so future analyses could look at a more rigorous comparison of past burn scars and soil burn severity. When we turn over to the ravage, the canopy mortality, it's essentially colored the same, where the red is high severity patches, 75 to 100% of the trees killed. And you can see that most of those patches match up. The configuration is slightly different, where there's some patches here in the middle. And Pepe is pointing out via the chat window that the Silver Fire also burned over the 1950s McKnight Fire. And so there might be some longer term effects. In the fire scars that I focused on were in the last 10 years or so. I'm going to jump through these fires fairly quickly. There's a little bit more information in the report itself, but I want to leave a lot of time for Chuck Maxwell's description of the 2014 sort of predicted fire season. So let's jump to the Haroso fire. This burned mainly in spruce fir. It burned about 11,000 acres in the Pecos wilderness, and about 80% of it was in the spruce fir, about 20% in the mixed conifer, and you'll see a fair amount of high severity. So in the soil burn severity, about 34% was high severity. One of the things we tried to at least comment on in the report is that the relationship between the forest type and the burn severity. So when we can look at the ravage data. It's fairly similar for the Haroso fire, but this is appropriate for spruce fir. Spruce fir is a forest type that naturally or characteristically would burn at high severity, and so these high severity patches are not surprising. Also in the report we talk a little bit about the blowdown. Much of the Haroso burned through an old blowdown, and so that the relationship between that blowdown area and burn severity, particularly soil burn severity, is of some interest. Jumping to the Thompson Ridge fire. This is a fire that in northern New Mexico, I should say these are all New Mexican fires. Perhaps I should jump back to the second slide that gives us an overview here. So far we've looked at the Silver Fire, the Haroso Fire, now we're looking at the Thompson Ridge, and then in a second we'll jump over to Arizona. Let's see if I can find that fire again. Let's see, Thompson Ridge. So Thompson Ridge fire burned about 24,000 acres. It mainly burned in the Valles Caldera National Preserve. Much of it burned in mixed conifer, so a higher elevation above the ponderosa pine belt. You'll notice in the soil burn severity map there's not much high severity. Only 3% of the area burned at high severity. So I would say, based on my reading of the literature on mixed conifer forest, that this is totally an appropriate sort of picture of the kinds of burn severity, soil burn severity effects you might expect in mixed conifer. There's a little greater patch of canopy mortality, so areas where 75 to 100% of the canopy was killed. And so you can see some differences here between the soil effects, particularly say in this central area where it was just a moderate impact, but all the canopy was killed. So this is an example where the soil burn severity maps and the canopy maps are telling us different things. But overall, we would still expect fairly big patches of canopy mortality in the mixed conifer. Another interesting thing to note is that the Thompson Ridge fire came right up against the Las Conchas burn scar. So these fires are sort of piecing together on the landscape, and this Las Conchas burn scar is still quite fresh. So it's not too surprising, given the severity of the Las Conchas fire, that there wasn't a lot of fuel for the Thompson Ridge fire to burn, and they were able to suppress it at that point. Tres Lagunas fire was the third fire, like Thompson Ridge and Las Conchas, started by a downed power line, and it burned about 10,000 acres in the sort of Pecos River drainage and up. Again, it burned mostly in mixed conifer, so you can see the Pecos River runs through here. It burned up slopes in a high value recreation area. There were some fairly large patches of high soil burn severity, and it also crossed over into the Vivash burn scar. Unlike Las Conchas burn scar, you can see that the fire continued to burn into the Vivash burn scar, although the soil burn severity was relatively low in that area. Similarly, the canopy mortality was relatively low in the Vivash burn scar, although there are some pockets of high severity. And you can also see that, excuse me, more patches of 75 to 100% canopy mortality in the main portion of the Tres Lagunas fire as compared to when we flip back to the soil burn severity. There are fewer patches, particularly on that western side. Switching over to Arizona, just again continuing with our quick overview. The Dosi fire was about 7,000 acres and burned mostly in chaparral. So one of the things in chaparral, it's a shrubby vegetation, and so it's not surprising that we see in the ravage maps almost complete or almost the whole area, 75% of it is 75 to 100% canopy mortality. This makes sense if we think about burning through shrubs as opposed to burning through trees, and it also makes sense that in much of the area we would have low to moderate soil impacts even though the chaparral is burning off completely. So this is another good example where the soil burn severity and the canopy burn severity are telling us different things, and in fact the differences between the two can help us understand a little bit about the kinds of fires we're seeing. The Soldier Basin fire, also in Arizona, burned about 11,000 acres, and this was in juniper and oak and pinon juniper. Again, it was set in amongst past burn scars, the Duke fire, the Aztec fire, the Wildcat fire. And the Duke fire from 2011 essentially formed the southern boundary for the Soldier Basin fire. And again, the soil burn severity had minimal impacts. In terms of the canopy burn severity, we see much greater area in that high category. And so again, this is sort of the difference if you start digging in and look at the fuel types, the forest types in those high severity areas. They are types where it's not as surprising to see the entire canopy removed, or 75% at least of the canopy removed, and still have low to moderate soil burn severity effects. Dean Peak fire, let's see, and oh, Don is on the line. Don, see, now you've outed yourself. You're on the line. I'm going to pin you down for the date of the next webinar. And he's asking a bit of more of a research question. Do current fires stop at the boundary of prior fire scars due to change in fuels, or because that's where control features are located, for example, roads? And that's an example of the kind of extended research that I hope the overview report will encourage other people to investigate. This report doesn't provide that kind of analysis, but hopefully it will provide researchers examples where they'll start to see things like the Soldier Basin fire and look at this line and say, well, what is driving that? Because it's actually, as Don knows, it's a fairly in-depth question to try to figure out what the suppression tactics were right at that line and why that was chosen. Even the simple analysis of adding in roads and trying to understand where the roads are can help a little bit, but is beyond what we covered in the overview. And as Andy Thode, our leader for the Southwest Fire Science Consortium, pointed out, there's been a previous webinar, Tessa Nicolette, back in the fall, I believe, covered some of the effects of past burns based on a larger analysis. And we can point you to the recording of that webinar. So the Dean Peak fire burned in an area of state land. It was relatively small, and so we don't actually have the soil burn severity maps or the canopy burn severity maps. So I'm showing an example here of the WUI maps, which we have for all of the fires, but since we didn't have the severity maps, we chose to depict this in the report. And you can see that essentially this green area is all wilderness, and coded in the WUI maps is very low density. The Dean fire was about 5,400 acres. The last fire is the Yarnell Hill fire, and of course you just can't mention the Yarnell Hill fire without acknowledging the tragic loss of 19 firefighters. And there's a lot of analysis and discussion about that loss. And I'm not going to even touch on that because I don't want to give it, to discuss it you really need to go into great detail, and we don't have that time here, and I don't have that expertise. So instead I want to just talk about the sort of setting for the Yarnell Hill fire in context with these other fires. So it's about 8,000 acres, burned mainly in chaparral. And one notable thing you'll see, unlike flipping back and forth between this and the Dean Peak fire, you see the Dean Peak is mainly in this very low density vegetation. Yarnell Hill has a substantial portion of the intermix. It was in more this deeper into the WUI, bordering on the interface. And Pepe has added another comment in the chat window about some ongoing research. So I got to rush along here because I want to make sure Chuck Maxwell has enough time. We did do some sort of summaries across all 8 fires. One of the things I want to highlight is the colors in this bar chart represent the different fires. So this blue is the Silver Fire, and what it's showing us is that the one large fire, the 138,000 acres that burned in the Silver Fire, drive the statistics for all the fires in the Southwest in terms of things like the forest type that they burned. So because the Silver Fire burned mainly in mixed conifer with some ponderosa and some PJ, that's what shows up as the largest proportion of acres burned in 2013. So it is these large fires that drive some of these things. Although Dean Peak and Soldier Basin and Yarnell burned substantial chaparral, because they were so much smaller, they don't show up in these summary statistics as much. When we look at the soil burn severity across all 8 fires, again, the Silver Fire dominates the statistics, but we can see that most of the area burned in low or sort of unburned soil burn severity with relatively small portion of high. And the same, well, the picture for the canopy mortality is a little bit different, and some of this is driven by those differences we saw in the chaparral where large areas of the chaparral burned they killed maybe the complete canopy or nearly the complete canopy, but did not have the soil burn severity effects. And we looked at some other statistics that I haven't gone into as much in this webinar, but things like how the forest in the burn perimeters had departed from their sort of natural conditions as mapped by land fire. And we see that most of the area burned was either moderately or highly departed from historic conditions. So in some ways you could make the argument that having fire in there, resetting those conditions may have been a good thing where it wasn't affecting lives and property. So with that, I'm going to end. I'm sure there are a lot of questions on the overview, but I would urge people to, I'll put the link in a second, read the whole report. And I want to jump right over into Chuck Maxwell's considerations and outlook for the 2014 fire season, because I think he just finished this like moments before the webinar started. And I know Chuck gave a webinar last year that was excellent. Chuck is a meteorologist for the Predictive Services. He works regionally for the Southwest. And with that, Chuck, hopefully we can hear you. I think you're on the moderator line, so you should be able to cut through even though I muted the participants.
Okay, can you hear me?
Yes, I can. So I will, let me give you the floor here virtually on the webinar system, and then you can take it away. Thank you.
Very cool. Thank you, Xander. And thank you, everybody, for joining us today. That was a pretty cool thing that Xander had just showed us. I looked at that before in the context of our seasonal outlook and found that very interesting. Before I start here, I just want to make it kind of clear, I guess, that our perspective is a geographic area one here at the Coordination Center, and the kind of things we're looking to foretell are basically where we're going to have large fire activity in a general sense, with the perspective of basically trying to manage resources for them. So Xander's looking at some really cool stuff, and they're really getting down into the actual fuels and stuff and the different kinds of stuff. We're looking more at just where those occur and the relative severity of them. But again, they're interrelated. I think it's kind of cool to show them both together here. I will show you a much simpler map of where our large fires were, and they will have some of the same fires that Xander showed. So moving on. Well, one of the things that we've found here, this is our fourth consecutive year, and we're not sure we found the right formula, but we're working on it. That basically fire season in the Southwest requires an alignment of a bunch of different stuff, a bunch of different factors. And not all these well, I guess a better way to say it is a bunch of these are kind of dependent on each other, which makes it a little more challenging. So I suppose there's always more work to do. But I'm always looking at drought. You know, the drought condition, is it out there? Is it bad? Is it getting worse? Our fine fuels, do we have fine fuels? Are they available to burn? Are they very continuous? Are they more loaded than normal? Is it how departed from normal are we in terms of our fine fuel availability? The seasonal temperature and precipitation anomalies mainly, like what's the setup over the winter and spring going into our fire season? Dry and warm, or cool and wet, or something in between? Real big one we've come to find out, it's kind of a hair trigger and makes it tricky, is the actual weather pattern that's occurring right now to the rest of fire season. We've come to find that the weather pattern itself and its subtle impacts, regardless of the climate anomalies, are huge players in the way things line up for fire in the Southwest. You have to have things align the right place and time to really get the activity that we're looking for. And then, of course, is the monsoon, which is, for the most part, a definitive end to the fire season for most of the Southwest. It also kind of resets the cycle for the fine fuels growth and the conditions leading into the following year. So basically, this is one continuous cycle. It doesn't really align chronologically. It's the way we set it up the first time looking at it. And I'm going to walk through each of these for the season and evaluate them and try and predict what the outlook's going to be. And Xander's correct. I did finish this about 30 minutes ago. So it's kind of preliminary, but hopefully this will stick through tomorrow. Again, I said we'd give a quick look back at last year, and what we define as a significant fire is just a fire which is in the top 5% of the size category, so the 95th percentile fire size. That ranges anywhere from 100 to 300 acres. If you're out of the eastern plains here of eastern Maxwell, West Texas, you're looking at several thousand acres. So one thing I wanted to do is just show last year's outlook in the context of what actually happened, to see if we have any skill or any value. And hopefully we do. So the first map here on the upper left just shows the one we'd issued in March, and it shows the significant fire activity that occurred March through June. I guess the key is here we're getting the majority of them within the area that we're seeing as above normal. We're missing a couple around the outskirts there. We're not exactly sure what time frame that was, but what's kind of interesting too is we move forward into May, into the outlook. The last one we issued about 45, 50 days later. We're updating things every month and kind of refining things, and as we kind of expand and refine our area, we hope as we get closer to the fire season, we're picking up a greater proportion of the large fires. And it seems that we did indeed do that for last year. So you see this dark red area down here as of early May is where we had basically said this is where we think it's a lock for above normal. The area it's hatched, we saw it kind of coming into if we got further into the season. And we saw, maybe 3/4 of our significant fires occur in this area. What's also interesting, as goes back to what Xander spoke to, is, and we kind of talked about this in our outlook last year, we anticipated seeing fire activity in mixed conifer because the conditions were conducive to that in terms of the drought and other things lining up. It just seemed like the heavier fuels regimes were ripe for the kind of fire effects and fire activity we saw. And that's probably going to be somewhat similar going forward. So this is always a work in progress for us. We just hope we're providing some value and some skill. So we'll start with this year by going through each of those factors, and we'll start with the drought factor here. So basically the upper left-hand map just shows the current drought monitor, and the lower left shows the outlook. And I could show you these for the past 5 years, and they'd be very much the same. It shows we're going to be in drought, or drought ever worsening throughout the Southwest going through fire season. So it's pretty much almost a semi-permanent part of our outlook, like a technology or methodology at this point. Really the best we're seeing even from last year's good monsoon is just very temporary mitigation of the long-term drought impacts. Really the best way to characterize all this is that we're just looking for much increased severity overall, especially in the heavier fuels regimes, and volatility during the season. Things are changing much more rapidly. Following a moisture event, we're seeing fire activity pick up much more rapidly. It just really has kind of changed the condition out there in terms of what people are used to historically in terms of moisture response and drying responses. Things dry much, much quicker, and impacts the fuels and everything else. So the second thing we look at, of course, is the fine fuels contribution. Not having any real great way to survey this electronically or digitally or other ways that we found really effective, looking back at the precipitation and then having Chuck drive across Arizona with his camera, there's some decent ways to find some information. So looking at the past monsoon, when I look at this, what each of these images shows is percent normal precipitation. The color bar in the middle kind of shows that when you're getting into the greens and blues, you're looking at above normal. So what we're seeing as you march here from kind of June to July to August to September, not every place was above normal for the whole time, but almost every place did get a decent soaking. And many places reported, top 5, basically wettest rainfall. Flagstaff, I think, came within 1/100th of an inch of its all-time wettest monsoon on record. So we had a lot of fine fuels growth. So that's something we've not had in recent years because we've had drought that's been so prolonged and sustained. We haven't seen a lot of fine fuels. This is a year we're going into the beginning of fire season with pretty fairly widespread and continuous fine fuels out there. And it's just a matter of time before these things dry, normally, and are available to contribute to the fire environment as part of our outlook. So bottom line, a big factor we've not had in a couple of years is indeed out there and requires a lot of monitoring and to see how things play out going forward. So a couple of pictures. Again, this is me in my car with my family, so this isn't a real survey, excuse me. But I was just trying to find out, I've gotten information from the field, and what we're hearing out there and seeing from some environmental data is, we're still seeing a mix of some gross and green up amongst the old carryover from last year. Areas further south in the region, down towards Tucson and Phoenix, are seeing much more cured environment. But just from some of the pictures I took yesterday coming back, Flagstaff still has some green around there, although it's in the media, not a great picture. I was surprised to look south from Winslow off the highway and see green all the way out there to the Mogollon Rim. I'm not sure how long that's been there or how long it'll last, but that's a surprising state at any time I'm out near Winslow to see green. I also was kind of curious over there near the Arizona-New Mexico border. You can see that there's quite an abundance of fine fuel, no doubt about that. But also, again, we're still seeing some new growth, some green in there kind of offsetting the potential. So I guess to look at it, we're still looking at a pretty good mosaic of conditions, probably more across the northern half of the geographic area than across the south. But that really just kind of takes the edge a little bit. It kind of complicates the big picture. And again, I put presently here in my bullet because if it rains again in the next week or however many days, this changes the picture again with a little bit more greening and makes this a real complicated picture. So that's the real issue with the fine fuels, is first establishing that they're there and that they exist, and then what is their state? Are they green? Are they somewhere in between? Or are they cured? And right now we're kind of looking at a mix of those factors. This is my family field trip to Sedona. Okay, so going ahead and look at the seasonal temperature and precipitation anomalies, kind of the setup period for the spring obviously is the winter, December through February time frame. And I'm going to show you a couple of slides of some similar stuff here. The upper left there with the arrow, it's temperature. Anything that shows on the yellow to orange is on the warm side, otherwise it's cool. And precipitation is a similar deal. If you're seeing warm colors, it's dry. As you get towards the yellower and greener, it's more towards typical. So basically what you saw over this winter, which I think most people are aware of, is we saw like 6 weeks without a cloud. It was a pretty darn dry and warm winter, especially as you move to the western half of the geographic area. Most of Arizona, western New Mexico, very dry, above normal temperatures. As If you went further east into the grasslands, we had some much cooler temperatures and some moisture. Also interesting, the precipitation factor down here is until we had the system come through, some might remember the weekend where we transitioned from February to March. If we had not had that precipitation event come through, we probably wouldn't have the green up we had to start with, and this map would have been a deep red color down here. So we kind of got a little bit saved or offset or mitigated by basically one event. Changed this map from an all less than 20% of normal to something where we had some areas that are a little bit more towards normal. Also kind of interesting to me, if I put my arrow here where I saw the green near Winslow, is that maybe there's some correlation there between the fact that we got some better moisture there and why the grass is green. Nonetheless, with the warmer temperatures and the overall lack of precipitation in the wintertime, our snowpack, and so our capability to melt out additional moisture into the soil for the rest of the fire season is just terrible. Snowpack isn't there; it's way below normal. The only place even close is way up near the New Mexico-Colorado border. So, kind of typical for what we've seen in recent years. Just another bad winter. So since we finished up March, I'll highlight March here. Again, kind of the same pattern. We saw a temperature regime that really was very similar, very warm across the whole, west and parts of the southwest, cooler to the east. Precipitation, kind of a similar deal. We tried to stay dry across the southwest, and that one storm came in, I mentioned before, kind of nuked parts of the southwest with some rainfall in early March, and that, along with the temperatures, kicked off part of the green up. It just kind of complicated the whole fine fuels picture we had. Didn't help the snowpack at all. Snowpack is not going to help us at this point. That's going to be a problem. So really, we continue to see an overall warm and dry trend with some variation. We did have the moisture event, which was substantial in terms of the fine fuel impacts. But the big picture climate anomaly through the whole winter and spring was dry and warm overall, drought not improving, and snowpack poor. And those are not good things, trying to avoid large fires. I guess I can speak to Xander had put a link in there, and we have a whole methodology that explains why we look at these things and why they're important. But if you haven't looked at it, go check the link later. It goes through and kind of steps through and explains a little bit better why we look at these things and how they're important to us. So here's where things start to get really interesting, moving back to the presentation, looking at the April through May time frame and trying to mesh kind of weather and climate prediction. I'll try and explain a little bit about that. But what we do here is we use all the climate prediction stuff from NOAA, and we look at that stuff. And that stuff is typically accurate. It just doesn't have the application that we're really looking for here. As I think I kind of showed earlier, knowing the anomalies is very important for the setup. But once you move into the growing season and the fire season, a single storm on one day of the month can change things for weeks. And so it becomes much more important to kind of blend weather and climatology together. So we take that approach here in an effort to try and come up with some past years of very similar global atmospheric and global circulation patterns and stuff, and see how the weather pattern might impact the Southwest along with the climate. And what we're seeing is a very bizarre and confused situation, which is not good for confidence. But some of you might remember the old polar vortex from the wintertime. What we're expecting that polar vortex is going to move north back towards Hudson's Bay where it's supposed to be. And I think what we're going to be seeing as we warm up through the spring is a jet stream that wants to move well north of the southwest, if you look at the red line I'm putting on the temperature map up here. I think the mean jet stream within the next 30 days is going to want to shift way to our north. But in the meantime, as we're seeing variations and fluctuations within that pattern, we're seeing a whole line of upper-level troughs set up off the west coast trying to dive into the southwest, and these could be big game changers. So what we're really seeing from these two maps together is a signal here on the temperature map for one of some coolness in the western part of the region, not necessarily moisture, coolness. And that's just indicative of some of the systems coming through there, maybe some wind associated with that. Again, not big rainers, but maybe a cooler condition than we've seen and a little bit below normal. And in terms of precipitation, I would not focus so much on the moisture in Arizona here as I would in the east. We do think the areas east of the New Mexico Central Mountain Chain, West Texas, Southwest Texas, and eastern New Mexico are going to get wet in this pattern. We're going to see some moisture impacts in Arizona, probably just a real widely scattered shower kind of thing, a light moisture deal. So again, it may not change the anomalies or the precipitation amounts, but I bet it will impact the fine fuels. So what we're really saying with this confusion is no real area of consistent, anomalies, a place where it's really warm and dry in the same place. The only place that seems to kind of be that way, if I had to pick one, would be maybe the southeast quadrant of Arizona, southwest quadrants of New Mexico, kind of between the two modes there. That seems like it may be the warmest, driest area overall. But again, what we're really seeing here, and this is the issue, is we're trying to look at climate, And we're looking at a pattern this spring where the weather is really driving what's going to happen over the coming months, and the climate anomalies may be nonsensical. So we'll see how that plans out. But again, we're looking, even right now, we're looking at a series of systems looking to move through with impacts. Any one of those systems slows down or rains over the southwest in a dry month. Good question, Pepe, I'll get to that one. And we have a game changer. If it rains a half an inch here in 2 weeks, that's going to green up the fine fuels and back season off by 2 weeks, and we have a whole new outlook. So that is part of our confidence issue. So there's a question there about how these patterns influence the winds, and I will get to that coming up. So I guess I'm kind of repeating myself here, but wanted to show the real big picture of where we're coming up with the jet stream prognostications we're coming up with. This big low, you can see on the map here, that was the former polar vortex, this whole system up here. And what's supposed to happen is that should never sit over Kentucky like it did anyway. But in the summer, it moves very far, much further north, back towards Hudson Bay, allows the jet stream to move further north, and that's going to result in a pretty rapid change on the whole system. At the same time, like I said, it leaves a weakness. You know, it's like a wave. You have ridges and troughs. It leaves a weakness along the west coast, leaves lows to drop into. As that low over the east transitions north, we think the ones over the west, and the models are showing this, are going to dig deeper into the southwest with some interesting impacts. So, again, a lot of variability. We're going to have it, basically transitioning from what we've seen, kind of warm, mild, dry, and breezy days, maybe a hot day or two, and then it transitions back to a cool day, a cold night with temperatures below normal, maybe a little moisture, seesaw effect. This is where I come to answer your question there, sir. So what I'm looking at here in terms of what happens, this is weird. This is what happens with the weather pattern with a strange global circulation like this. You get kind of an all-or-nothing storm track, feast or famine storm track. So what we've kind of been seeing, and we're already starting to see trends of that, is the jet stream wants to lift way far north. That's one of the modes we're looking at. That leaves us in a dry pattern down here, but not quite as windy as it could be. And the winds tend to be displaced a little bit further east. So we've had some wind events so far. We've had some pretty decent ones. We haven't had any real power line blowing down ones yet, and we certainly haven't seen anything in 2011. So I guess what I argue to say is that we're always going to have spring winds here in the southwest, dry spring winds. Perhaps this year they will be not as severe or widespread or as long-lived as typical. Especially when I look at this second pattern over here, the southern stream track. This is what we see coming for this weekend and again next week and the next weekend. These systems are coming in. Now, here's what's interesting. You will get a burst of wind, strong wind ahead of this system. It'll be followed immediately by clouds and a cool down and maybe even some light moisture. So it's, again, I think back to 2011. It's different to have wind followed by clouds and moisture than wind followed by wind by wind. So I think to answer your question there, is the winds we're going to have are probably not going to be as widespread or severe as we have seen. When they are really bad, they're probably going to be that much better chance or followed by cloud cover or some moisture. And so it just doesn't look quite as bad as it certainly could be. It may be less windy than normal overall. And the bottom line is, in terms of the area, we're not seeing any one focus where this stuff all lines up for any sustained period. What you really want to see is all these things, the jet stream, the patterns, the anomalies line up in the same place for a couple weeks on end. Then you definitely see fire outbreaks. When they jump around the area, you see a real confused pattern like we've seen in the previous years. Now comes a really interesting topic, so I'm not even sure I want to go here. We're not really sure we can predict the monsoon. We're not really sure we even know what it is. But we still try and give it a go just to see if the setup is there. One of the big keys to the monsoon is you want to have some kind of upper-level ridge. Hopefully, usually it's over the southwest or Four Corners vicinity or maybe even the Great Basin. And that allows moisture to be pumped up from the Gulf of Mexico towards the area. This pattern here, again, is using some of the same technology we looked at, the same methodology. It includes a trend towards a moderate El Nino, which is actually predicted to occur, I think, over the summer into the fall. But El Nino impacts in the summer in the southwest are very strange. They tend to weaken the system. And so what this indicates to me is there is kind of a setup to get moisture into the southwest. But with this kind of flow of the jet stream pushing into Arizona, it may push a bunch of the moisture further east. So we'll have to watch. We always have to watch this. It's almost a day-to-day, week-to-week kind of thing. If this holds true, this might argue for being a little wetter for areas east of the divide. And after an initial burst in Arizona, it may be drier than typical summer. We may have additional issues later in the summer that we might not normally look for. So I'm going to go through, because I know there's lots of different ways people look and use at this, and try and summarize this in a number of different ways that leads to the outlook we give. So Just to briefly recap, drought, yes, it's not there. It's not going to get any better real quick. I have real concerns, as we've seen in recent years, about the fire behavior and then the resistance to control and the heavier fuels, which I thought was kind of interesting when I saw Xander's work there, the work done by you guys in the mixed conifer regimes and some stuff. That's exactly what we're talking about. Some of the anomalies in the drought years we looked at and stuff, I think someone mentioned, went back to the mid-50s in terms of we saw conditions like this. And I've heard several people, and I've seen fire maps and stuff from the 50s, and they were in that same regime. So you see things line up like that, and it makes you wonder, are we going to see more fires in that same regime? Well, if they start, probably. Going on to the second factor, fine fuels condition. I put a star next to the couple of these bullets because I think these are the overriding factors for this year. The key here is that we have fine fuels across almost the entire geographic area. The only real issue now is whether they're available to combust right now or later or not. So right now we have a mosaic of greenhouse will be an ongoing complicating factor, especially with the moisture impacts we're anticipating. But I'd say on the whole, the further south you go, the worse things are, the worse off things are, the more cured they are, and the more available the fine fuels are for fire spread. Seasonal temp and precip, I think we hit pretty well. Basically the whole spring and winter will average out warm and dry, but with significant variability that's not unimportant, and that's where I get into the weather pattern part. The pattern supports basically, as we just said, a highly variable temperature and moisture conditions, with I think the biggest key being, again, no real focus for critical fire weather conditions or patterns. Past research is real old, back in the 70s, has shown time and time again that large fire outbreaks are based on weather patterns aligning with all these other things. And we're just not seeing those things line up in a certainly not predictable fashion, but it just doesn't look like they're lining up, so we can draw a circle somewhere and say this is what's going to happen. I do point again back to that kind of southeast Arizona, southwest New Mexico area. That does seem like an area that would be drier in this overall pattern, but again, low confidence. The monsoon, I'm not sure I want to speak to this again, but again, I think we're looking at some confusing signals for the monsoon. I guess the real watch out here is for Arizona to maybe dry or be drier than normal through the summer, which would be a problem. Oh, it doesn't show up right in the way I want to do it. Okay. So what I was trying to do here, Xander's, any way I can show the overlays or no?
No, I'm sorry. We didn't. Yeah, we can't do the animations.
That's okay, my bad. No worries.
Sorry.
Okay, but no worries. It's pretty good. So what I tried to do here is I tried to do like a visual for you to see the areas I'm looking at. So I put the drought layer in red, fine fuels available in green, seasonal temp precipitation, where I thought it would contribute to above normal in orange. Spring and early summer weather patterns in blue. You can see how it's not a very big area, and that's what concerns me. And the monsoon we didn't include. So what we really look for is, this is again looking at more of a spatial perspective, done in PowerPoint, a cheesy one, of where these things will align. And this is just, I'm looking at this for the whole fire season. I'm not sure all these things line up at the same time, and that's an issue. And again, what's a real big issue is that the weather pattern is not necessarily supportive of big fire outbreaks across, but maybe 25% of our geographic area. And that's kind of a necessity for us to have large and sustained fire problems. But I have yet another way to show you before we start wrapping this up. And what I did was summarize, and it kind of combined, I guess using numbers and colors here, how many of the top 4 of these come into alignment at some point or other during the fire season to contribute to an above normal year. And again, I focus on this area here where I'm seeing 3 or 4 of these factors come into alignment across the same area I've been talking to. As you kind of radial out from there, you're seeing less and less because you're getting cooler impacts across here, coolness and some moisture across the north, and we think some substantial moisture impacts eventually across the far east. So really we're kind of honing in right now on an area that's more towards the south central portion of the region. A huge part of this, though, is I look at this over like a 3-month period, and really, especially with the fine fuels and the weather stuff lining up, I'm not sure these are all going to line up at the same time. And why that's important is if we get a big rain event or something down here, say it happens in southern New Mexico and all the grass turns green, and then the wind blows the whole next week, it's not going to have an impact. So that's how things occur, the order in which they occur with the weather patterns is very critical. So that's my concern right now with the variability is we don't see something like that that shows up that's predictable or that's not enough of a large enough area to have a real impact in the way we might think it might. So with that, I will show you the map I just updated here about an hour or so ago. What we're basically looking for, first of all, I'll describe the map real briefly in the lower right here. kind of two different time frames here. This is actually valid from now through July. Our fire season typically winds down in mid-July, except for 2011. And what we're looking for is for conditions eventually to blossom sometime in May into June, the peak fire season, primarily probably across the areas where you saw everything align there, the southeast quadrant of Arizona, southwest quadrant to New Mexico, perhaps up parts into along the Continental Divide, portions of the Jemez. And then later on, with much uncertainty, potentially seeing this increase as it typically does further north and west across northern half of Arizona, the Four Corners area. Also want to point out that we're already seeing signs of moisture impacts starting to whittle away at the eastern part of this area here, and that will probably change as we go forward. So again, we're kind of focusing on an area here that's kind of focused right over where we have some of our current fire activity. But basically for the rest of this month, we're looking at continued weather variability with a huge mix of impacts, including wind, a little bit of moisture, some cold temperatures. And we're going to continue to see some of the green up ongoing and probably some new green up. And not so sure that the windy, dry impacts we're going to see are going to be all that impactful unless they happen to occur probably right over these exact same areas. An interesting piece of information I'll pass along from the fires going on down there. The brown fire that went down on the Coronado National Forest, I got a call from the folks earlier just to pass along. It's kind of interesting. They said that the fire was going out in the heavy fuels down there, and it was dying in the oak brush at night. So they're not exactly sure why that is, and that kind of confuses me, but apparently something is not quite ready to align down there to make that thing go like they thought it might. Anyway, that's just a little piece of ground intel I got that usually confuses my regional perspective. But so as we go further into the season, into May and June, as the jet stream lifts north and we see more warming and drying, we hope, we suspect that above normal potential again will blossom over the area that I put down there. And a lot of the drivers are going to be the drought impacts and those heavier fuels. We're going to have the fine fuels in alignment. We're going to need to have warm and dry conditions and some lightning ignition potential to start up to get that all going. And then again, as we move to the monsoon stuff, that almost always happens. It almost always happens by mid-July. And even when it's a little bit drier than normal, it still has a pretty major impact. But again, I would be watching out in parts of Arizona if that pattern we looked for does indeed come true. You do not want southwest winds in Arizona in late July and August. That's not a good sign. We'll be watching that as well. And again, as I think I spoke to you, the real deciding factors here going forward is the spring weather pattern and the temperature and moisture impacts, including the fine fuels growth. This is really a game changer right now, and we're seeing a lot of confusing signals, a lot of things lining up, again, for not severe conditions, even if it doesn't rain a lot. And it's a confused signal. It's kind of an interesting deal. It's like a hair trigger. The underlying conditions are there, the fine fuels are there, the drought is there. The weather pattern's really holding things back. If the weather pattern changes, we'll be off to the races in a short time. Regarding the monsoon as well, if we don't get really hot during this spring, we don't tend to have a typical monsoon. So really, we'll see how that plays out as we do every year, but you need to have some kind of heat build over the southwest in May and June before you get a good monsoon system kicked in. If we screw that up, we may have a screwed up monsoon with impacts beyond our capability to recognize. So I think this is my last comparison here. I try and compare things in many different ways for people. We are, again, seeing, I guess I have to reemphasize the low confidence right now. Because of what we've been seeing in changes in the weather models going out a few weeks and the short-term climate models showing all kinds of moisture impacts, we have a lot of questions still. There's indications it may continue to moisten into May. We're not totally going with that right now, but we can't just count that. But bottom line, two main things I see with regard to past years that people may relate to. So last year and 2012 were years when we had some, excuse me, I had to click something off there. We had some of the same variability in the spring that kind of held things back. We had severe underlying conditions. We had some weather variability that continued through late April, mid-May with a little bit of moisture, and it kind of set things off. So really, I could see this year playing out kind of like last year or 2012, which Xander showed you and I showed you in my initial thing, but with a fine fuels component that was not there those 2 years. So that could change the game in terms, if it turns out that way, I would expect to see a little bit more widespread fire activity and stuff not just being constrained to the mountains because we have fine fuels to spread them in. But again, that's a big if. Another possibility, which looks like it's almost becoming increasingly possible, if not likely, is that the spring moisture variability made it to be more like the 2009 year, when we actually had a big burst of moisture, several in May, and a really kind of poor or meager overall large fire season in terms of impacts. When you get, big rain events in the heart of your fire season in the Southwest, that's just not conducive to fire. It is probably conducive to the following year, but certainly not that year. So we're looking somewhere between these two, somewhere between, some having a little bit less fire activity, having big high-impact fires, or maybe having the bad underlying conditions quashed by the shorter-term weather conditions. Somewhere in between those, and they're both very volatile situations. But the one ongoing factor is this drought condition. And I highlight this over and over and over to people because we've seen the impacts of this. Is the fire behavior in the fuels, especially as you get to brush and timber, and the rapidity with which fire behavior picks up after any kind of moisture or cooling event is extreme. And so we're trying to get people to recognize this right away from the get-go that, hey, if you're used to having a couple burning periods after a little bit of rain, to knock your fire down, maybe you got one, or maybe you have a half a day. Please understand that things are different, and it's not going to be like it was 20 years ago with regard to how that all works. That concludes my look at the 2014 fire season. You can see there's still a lot of questions. I've answered some, probably raised some others. Does anybody have any questions or discussion?
People, thanks so much, Chuck. That fascinating look into what we might run into this summer. I'll go ahead and we're sort of at the end of our hour, but if Chuck's willing to stick around a little bit, we can take a few questions here, and you can type them in the chat window, and I'll also go ahead and unmute the line so you can just verbalize them. Yeah, I really appreciate you rushing to get this completed for today's webinar, Chuck, because it's a sort of a mysterious year, particularly for those of us without your insight. So it helps to kind of have you outline the factors and things like the lack of heat buildup in May, June affecting the monsoon. It seems like it could go a lot of different ways. Anybody out there have a question? Oh, there we go, Pepe. Good.
Not a question, but I think I really agree with you about the fine fuels in the lower elevations. We have a project in southern Arizona, and being out there, I mean, in those kind of that from 4,000 to 6,000, those grasslands and the woodlands, they have a lot of fuels right now, basically from the good monsoon last year. And to tell the truth, I'm surprised that we haven't seen more fires in that elevation right now.
Right. Well, I guess, and that speaks to two things, is you're right. One is, are they cured? And it sounds like they probably are, mostly. But one of the key factors early season is it's exclusively human ignitions, right? So we need to have humans out there and wind to drive it, and some warmth and wind to drive us along with the human ignitions. And if those things don't line up, you don't get those fires despite the fuel bed.
Yeah.
So yeah, good. Sorry, excellent feedback. I appreciate it.
Marcus, thanks for your comment in the chat window. I'm glad this is helpful, and we'll hope. Obviously, Chuck updates these predictions. I think what's the next update is mid-May, right, Chuck?
Yeah, we'll be doing our final one there in mid-May, and then we're in the thick of it, and hopefully that's the best we can do, and it's right.
I'm not sure how people use this information, but I wonder what people are thinking in terms of this information for doing prescribed fires and stuff like that. Because it seems like if you're going to get some of these little waves coming through, you theoretically you could be doing some prescribed fires right now, assuming that you're going to get a little wave in the next coming weeks or so. But it is so dry out there that maybe people aren't willing to take that chance.
Well, let me address that. It's an interesting question. I've had a bunch of questions, as you might imagine, because people are trying to get stuff done in different fuel regimes, right? One of the things I caution them is, you better be darn sure if you're going to burn into heavier fuels that we got the weather right. Because if it gets up in there and gets going, it's going to take a lot more than a little cool down to put it out, right? So I've been really cautioning people who have been asking me for advice in those kind of regimes to say, you know what, you better make sure you get to me with exactly what you're trying to accomplish. Tell me exactly how many days you're looking at, and I just try to say, you know what, predictability may not be there to have a 4-day window at all, especially where you got the drought and the drought fuel impacts and so forth. Maybe the finer fuel stuff is in piles if they're still out there to burn, something to do, but broadcast burning, I think, in the springs we've had, where things are going from high to low so fast, can be a challenge.
Other questions out there? Well, hearing some.
This is Andy
Oh,
Rhodes.
great. Thanks, Andy.
And I was curious because, you know, in my stuff, we've already had a 175-acre wildfire and a couple starts in town, and so we've got the human ignitions rolling, it seems. They've actually gone into fire restrictions both in the city and then starting in the forest this Friday. But then, you know, I'm looking outside the window today, and we seem to keep getting these cooler weather trends. So it seems like we sort of start off with a kick, but there's these, what you seem, you know, describing as almost weekly coming to us now. Cooler weather trends is what you're talking about.
Right. Exactly. Yeah, you're right. And that stuff kind of kicked up on, they gotten warm and windy, right? Basically ahead of the system. So having those human ignitions, that was a ripe time for it to happen. And if we'd kept that weather pattern for a week, we'd have had big problems. But as you said, we're just not sustaining that. That's really what's killing it now.
Yeah.
You know, it's interesting because it took me a decade to figure this out. I couldn't for the life of me figure out why it'd be so dry and the ERCs would be so high and there would be more fires. And what it really came down to is it just didn't align on the day of, or conditions changed enough, overnight temperatures. I guess what I really found out, the Southwest is such a volatile fire regime, it doesn't take a lot to knock off kilter.
I think that piece about the winds too. It seems like, you know, that's been critical these days. You know, we could have a day or two that is windy, but it's not nothing like 2011 where we have a week of 50-mile-an-hour winds type of thing. So.
Right, and we look at some other stuff with the winds. We look at stability and stuff too, and that's not something we really looked at a lot in the fire behavior. But having it be windy and unstable is a huge difference than when it's behind a cold front. We have lots of windy days on west or northwest winds, but it's not very unstable. Fire, there's no third dimension of the fire activity. Then it all goes sideways.
Yeah.
So we've noted that that's also a game changer as well.
Yeah. Okay.
Well, I want to thank everybody for joining today. Chuck, particularly, thank you for your presentation. Great view of the upcoming year. And, you know, I think we should talk more about the potential for inserting kind of your look back at the 2014 year when we do our look back at some of the vegetation conditions for the big fires of 2014, because I think it is helpful to have something to compare it to. I mean, your comparisons with past years like 2009 and kind of the wet May, etc., is very helpful, and we should have a similar ability to look back for some of these fires.
Yeah, that'd be great. That would really help to validate what we're trying to do and be a good collaborative effort.
And as a final note, Julie has reminded me that we may still have Don Falk on the phone to pin him down, but I think he may have left. Don, are you still on the line? I think he slipped out before we could pin him down on his webinar date. But we'll go ahead and do that, and if you're already on the Southwest Consortium email list, you'll get an email about that. And if you're not, I encourage you to do it. So with that, we'll end the webinar. Please do take a minute to answer we'll have a quick survey at the end of the webinar, and please join us for the next one. Thanks again, Chuck.
Thank you.